All right, let's look at number 6. So 6 is very similar to 5, but they did not give me the linear graph. Instead, they gave me the equation. And so I'm going to have to graph that. Or I could go the opposite direction. They gave me the explicit formula for the sequence. So I can identify my 4 terms, okay, and then work backwards, okay? There's no, doesn't matter what order you go in. But we should see that these are very similar, just the notation is different. I have a 2 in front of my x, I have a 2 in front of my n, -1, -1. But let's just go review graphing. So right here, this is in slope-intercept form, y equals mx plus b. So my b is my y-intercept. So I'm going to go graph a point at -1. And my slope is 2, not 2x, so 2 over 1. So I'm going to rise 2 and go to the right one. So rise 1, 2, right 1, rise 2, right 1, rise 2. And I want you to go through the entire graph because this is a function and it's telling me it's continuous. All right, so I'm going to draw. Oh, it's very hard with this pen. Ooh, not perfect. Sorry, but that is a linear function. That is ugly. Ugly. All right, so this is a continuous graph. It's going to go forever and ever and ever. I'm going to let you answer domain and range, okay, for either of these. But I want to show you 2 ways that you can find these first 4 terms. So one, I can use the graph, okay? So when a sub 1, so I'm going to go when x is 1, my y is 1. Then I'm going to go to a sub 2. So a sub 2, my y is 1, 2, 3. Okay, I'm going to go to a sub 3, 1, 2, 3, and my y is 5. A sub, oh, I already used green. Let's go purple, 4. And my y is 5, 6, 7. All right. So a couple things we should see is my common difference here is a plus 2, which is the same thing as my slope. All right, so same thing as slope. Another way that I could have found these values is I literally could have taken this one and plugged it into my equation. So I'm going to show you that. So I could have done a sub 1 equals 2 times 1 minus 1. And 2 times 1 is 2. 2 minus 1 is 1. So there's a sub 1. Then I could have done the same thing for 2. A sub 2 equals 2 times, I got to plug in, 2. And then subtract 1. So 2 times 2 is 4. 4 minus 1 is 3. So a sub 2 is 3. And I could go so forth. So that is another way that you could have found the first 4 terms. I want you to finish the domain and range for both of these, and whether it's continuous or discrete, and check your answer on the answer key. All right, number 7, we are given the discrete function f of x, determine the sequence that would be represented. Then graph both the discrete function and the sequence. Then determine the type of equations that would represent the relation. Lastly, state the domain and range. All right, so here, let's finish filling in the table. All right, so I have -3, -8, -2, -6, -1, -4, 0, -2. I'm going to figure out what that is, also the common difference or what my slope is. So to get from -8 to -2, or -6, I'm adding 2, adding 2, adding 2. So plus 2 is 0, plus 2 is 2, 4, 6. And if you notice, it told me that this is going to be a discrete graph. So all I'm going to do is my coordinate point. So 1, 2, 3, 5, 6, 7, -8, -2, -6, -1, -4, 0, 2, 1, 0, 2, 2, 3, 4, 4, 6. Okay. And we could keep going either direction. But I'm going to leave it like this because, again, it told me a discrete function. All right. Now, the difference between a discrete function and a sequence is a sequence always starts with the first term. So my first term here is when my x value or my sub is 1, my y value is 0. And then it would go a sub 2 is 2, a sub 3 is 4, a sub 4 is 6. So this sequence is just going to be 1, 0, 2, 2, 3, 4, and 4, 6. All right, so there's the difference between a discrete function and a sequence. A sequence always starts with your first term. All right. So now what you can do, or what we can do, is we're going to actually create the sequence formula first, and then I'll change it to a function. So I'm going to have a sub n equals a sub 1 plus n minus 1 times d. Okay, this is kind of crazy. My first term is 0, and my common difference is that plus 2 still. I can look at my graph over here. I can look over here, plus 2, plus 2. So I'm going to plug a 2 in, and now I'm going to backwards distribute. So I have a sub n equals 0. 2 times n is 2n. 2 times negative 1 is negative 2. And I'm going to combine like terms. So I have 2n, and negative 2 plus 0 is negative 2. So here is my formula for this sequence. To write it as a function, all I'm going to do is change a sub n to f of x and n to x. So this is going to be 2x minus 2. All right. Both of these are discrete because that's what this one told us in the problem. So discrete, and this one is also discrete because it's a sequence. My domain is just my x values, and my range is my y values in my table. Okay, so let's go write those. Let's see if I can get both of those in here. So my domain, why does this keep coming up? Negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. And my range is my y values, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, and 6. And then for my domain over here, we're just going to start at 1 because that's where I have my first term. So 1, 2, 3, 4. And then my y values are the range, which is 0, 2, 4, and 6.